Hey Carter, this is 2-6, or the first half of it probably. This is the homework problems. The last three are probably going to be the harder ones. They're the longer ones. Those are graphing, but the other ones are not hopefully too bad. This is all graphing rational functions. This is the same as what we've been doing, but now you're just taking all that information and shoving it into a graph and showing what it looks like, okay? So we're still finding VAs, HAs, holes, slant, asymptotes, that type of thing, okay? So, one thing, you should have these guys in your brain of like what these parent functions look like. So this is 1 over x again. He is the boomerangy guys. He has a VA right here at x equals 0. He has a HA right here at y equals 0, okay? That is what a 1 over x looks like, okay? You should know kind of what he looks like, okay? 1 over x squared is that volcano. You should kind of know what that parent function looks like. He also has a va and a ha at x equals 0 and at y equals 0. Ha is at y equals 0. Va is at x equals 0. Good? Just remember what those guys look like. 1 over x squared. Got it? All right, example 1. Use transformations to graph the rational function. I don't need to like find the va and ha and all that crazy weird stuff. I am going to just dissect this guy because of his parent function. So if I like strip all these numbers away, if I strip away the 2 and I strip away the 3, this is 1 over x squared. So he's going to be a volcano. Now I just have to decide from there what those numbers are doing. So like, how does the 2 move it?
Moves it to that way.
The plus 2 moves him to the left 2. How does the 3 move him? Up 3, okay? So here's what I'm going to do. When I go to graph it, I'm going to start with my graph. Normally the vas and ha's are here and here at 0, right? That's where my va and ha are, at 0, 0, right? Now I'm going to go left 2, and I'm going to go up 3, and there's where my vas and ha's are going to intersect. You see what I just did? No, I only went up 2. Left 2, up 3. Here's my va, here's my ha. Okay? So instead of him being at 0, 0, there's where he connects. I go left 2, up 3. There's where he connects. And now what do? I got to draw the volcano from there. But that's how I can move him. Rather than doing all sorts of weird, crazy things, I just remember the transformations, find the parent function. That's what he looks like. Got it?
Can you pause?
Yep, I can. Okay, good. All right, when they ask you to graph a rational function, this looks like a huge long list of things, right? 1, 2, 3, 4, 5, 6, 7. These are just possible things that can help you graph a function. You may not have a va. You might not have any zeros. You might not have certain things, in which case you can just ignore some parts, whatever, right? But these are all 7 of these things can help you figure out what the function should look like, right? So determine the y-intercept. I'm going to write notes off to the side over here, and then we're going to actually do it. So how do you find a y-intercept?
0 in for x.
Okay, so yeah, so I'm going to put 0 in for x. So you have a note off to the side of how you find the y-intercept, okay? If I plug 0 in for x, y equals, this would be 0 plus 3 over 0 minus 2. The y-intercept is going to be at -3/2. That's what my y-intercept for this function is. Okay, I'm going to go to the y-axis, and I'm going to put -3/2, which is -1.5, and I'm going to put him right here. There's where my y-intercept is, my pink little guy. Okay, you see the little pink dot? Y-intercept, little pink dot, -3/2. That's where he is. Okay? Good, good?
Okay.
How do you find an x-intercept?
Y.
0 in for y. Question, why does it say s on the end of x-intercept, like there could be more than one, but not an s on the y-intercept? Can you have more than one y-intercept?
No, because you
How's
have
come?
pass the thingy.
He wouldn't pass the vertical line test. If he has 2 of them, he wouldn't pass the vertical line test. But he can have more than one x, right? Okay, just FYI. All right, determine the x-intercept. Plug 0 in for y. So I'm going to do that to this function. 0 goes here. I have x plus 3 over x minus 2. Now what?
Nasty.
It's not nasty. Multiply the x minus 2 over, because then what happens?
Cancel out.
Yeah.
Negative.
Times 0 makes them go away. 0 equals x plus 3. And x equals
Negative 3.
-3. That's my x-intercept. So I'm going to go to -3. And I'm going to put a dot right there.
Oh, come on.
So I have my x-intercept, my y-intercept. Aubrey, are you writing this down? You should be. 3. Identify vertical asymptotes. How do we do that?
Set the
Denominator equal to 0. Okay? Really, if you want to know, when you're doing number 2, which is determining the x-intercepts, we put 0 in for y, right? But we end up multiplying the bottom over. So really, you can find the x-intercepts by setting the numerator equal to 0. Does that make sense? Because that's essentially what you're going to do, because the bottom's going to go away, right? So if you want to, instead of putting this off to the side on number 2, you can say set the numerator equal to 0, right? Because the bottom's going to cancel off when you multiply it over. Does that make sense? Shake your head and say yes, even if it doesn't. Okay. All right. Okay. So denominator equal to 0 for the VA. Let's go. Denominator is x minus 2. So x minus 2 equals 0. Where's the VA? 2. Okay. I'm going to graph it on my thing. Positive 2?
Yeah.
There's my VA. Okay. There's the VA. Okay. Determine whether he has a horizontal or slant asymptote. How do we do horizontal asymptote, by the way? How do I figure out the horizontal ones?
With the 0 at the top.
No.
Bottom.
Mm-mm.
And for x.
Mm-mm.
Wait, don't tell.
Okay. N and M. If N is bigger than M, if he's top heavy, what happens?
Falls over.
Falls over and there is none. If he's bottom heavy, like the second one, if N is smaller than M, he's bottom heavy, he's going to sit at
0.
y equals 0. If N equals M, you look at the leading coefficients, like the leading number, LC over LC. Okay, that's for your ha. And then how do you find a slant? I'm going to put that off to the side over here too.
Is that where you plug in?
A slant is if
Oh,
N
so look at
equals
the top.
M plus 1, right? Like 1 larger. If your N is 1 larger than your M. How do you find the slant asymptote? Long division. Who said that? Nice. Long division. You're dividing it. All right, so let's decide.
Why can't we do synthetic?
You can technically do synthetic if you want to, yeah. Yes, you can. And it's everything except the remainder. So yeah, you should be able to do synthetic division. You should be able to do synthetic division. I guess unless, Reese, let's say you have x to the third plus 4x plus blah, 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 over x squared plus 5x plus 6. You cannot do synthetic division to that one. Does that make sense?
We can only do synthetic
When it's x plus something or whatever on the bottom. Yeah. If it's x squared on the bottom, I would do long. Unless you could do synthetic to this guy if you wanted to and say that multiply to get 6, add to get 5, right? That would be x plus 2, x plus 3. So you could, if you wanted to do synthetic division, you could do it twice. Or just do long division once. Make sense? So that's where, yeah, that's where, you know, you have to decide, okay? All right, let's do horizontal asymptotes. For this function right here, what is n?
1 over 1.
Yeah, he is to the first power, m is to the first power, so 1 over 1, so that means I do the LC over LC. Okay, what's the leading number of the top?
1 and 1.
1. The leading number of the bottom is 1 also. That's kind of anticlimactic, but whatever. So y equals 1 is my ha. I'm going to go to 1 on the y. Boop, 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 boop. There he is.
Can you?
Okay. Y equals 1. Slant asymptote?
No.
None, because he has a ha. If he has a ha, he won't have a slant.
So 1 equals that now.
What?
For the next part.
Oh, yes. So, number 5, determine where he crosses the horizontal asymptote if he does at all. He might not. Okay? So, I want to know where this function hits 1 at. He might not, but we're going to see. So, I have 1 equals x. Is it x minus 3? I forget. Plus 3 minus 2. Okay. X minus 2. Okay? Now, what do? Multiply it over. Now, here he won't cancel, right? Because you're multiplying by 1. So I have x minus 2 times 1, or just x minus 2, equals x plus 3. And what? You subtract x. And if you want to add the 2 over, sure, whatever. You end up with 0 equals 5. What does that mean?
Yeah, nothing.
Doesn't cross the horizontal asymptote.
No crossing.
No cross the ha. Okay, so that ha he will not touch. Sometimes I said, like, he will do one of these weird things where he'll go up and he'll come down and he'll cross right here. But he's not doing that in this case.
So we have to find the ha in order to determine if it crosses?
Yes, because you set him equal to that. Yep.
How does that make sense? How can it touch it?
What?
Set equals. Isn't a horizontal asymptote where it doesn't have
So horizontal asymptote is technically, he's kind of a little bit different than a vertical asymptote. A vertical asymptote is like where there is no x value, so you cannot cross a vertical asymptote. But a horizontal asymptote more has to do with the end behavior. So like what's happening forever to the right and what's happening forever to the left, right? That's the only reason why that horizontal line exists. In the middle, he can cross if he wants to, whatever. But on the forever to the right and forever to the left, that's the reason why the horizontal asymptote is there. So he can cross in the middle, because sometimes he will do that. Like he will do one of these, and then he'll level off. I don't know. Okay?
So if it, if it has a slant asymptote, then the slant asymptote equation is equal to the original.
No, because he won't ever cross the slant.
Oh, right.
The only time you have to do that is if he crosses a ha. Yep, he won't ever cross a slant, and he won't cross a va either. So he won't cross a va, he won't cross a slant, but he could cross a vertical or a horizontal asymptote. Okay, test for symmetry. I don't want to test for symmetry, but do you remember how?
Vertical line test?
No, not necessarily, because we're trying to graph it, so we can't do the vertical line test if we don't have the graph already.
Oh, that's
Testing for symmetry was like if he's symmetric with respect to the x-axis, if he's symmetric with respect to the y-axis, if he's symmetric with respect to the origin, right? What do we plug in for x-axis symmetry?
Negative y.
Negative y, so x negative y. We see if he flips back to normal. Y-axis symmetry, we plug negative in for x. Origin symmetry, we plug negative in for both. And we see if he changes back to the original. And I want to do that, so we're not going to. No. I won't make you test for symmetry, but that's how you do. Okay? Determine the behavior of f on each interval. So what you could do is if you don't have any points at this point and don't quite know what he looks like, you could plot some points. Like I'm going to guess that this is what's going to happen. I'm going to guess because I know what rational functions look like. I'm going to guess he's going to do one of these. Right? And he's probably going to do the same thing up here. But I don't necessarily know where any points are located up there. So I don't know if well, he's got to. He's got to do one of these up there if he does one in the other corner. But I could plot some points. Like I could plug in 3 into my function and see where he's going to touch.
So that's what we do for 7. We just plot points.
Yeah, if I plug 3 in, let's see what I get for 3. 3 plus 3 over 3 minus 2, 6 over 1. So he'll be at 3, 6. 3, 6, he'll touch there. I could plot in some other points if I wanted to, but he's going to do that little L shape in the other corner. So just do as much as you need to in order to get him graphed. 3, 6. If I plug in 3, I get 6. You could plug in 4 if you wanted to. 4 would be at 3 halves. Or 1.5, I think. No, that's wrong. I don't know.
Okay.
Okay, good? Happy with that? Okay, let's do like one little titty bit more and then we'll be done.
I missed the last part. Let's look at the graph for a minute. So we didn't do number 7 either. No, it's just plot points.
Determine the behavior. But yeah. Number 7 is basically like, if you don't have enough points, pull out some points. Determine the behavior of f on each interval. So like we have intervals going on. Oh, maybe the behavior. Like, is he increasing or decreasing? I don't know that that's going to be helpful. So 7, like in place of 7, I would just plot points if you don't have enough of a graph already established. Plot some points like I did. I plugged the 3 in to see what we got. Okay. Good? Let's do one more and then we'll stop. Okay. Some of these take a little bit of time. Yeah. All right, so this is another rational function. 4x over x squared minus 4. Determine the y-intercept.
So I have a question.
Yes, dear.
Is this literally what we're going to do on our homework? And like then graph them?
Yeah. On the last 3 at
So
least.
we'll need graph paper?
Possibly. Do you want
Or
graph paper?
like graphs?
Like little graphs?
You
Yeah.
have to graph every single problem.
You have to graph every single one? Oh. Oh. Well, that's unfortunate.
Yeah, except for 18.
Except for 18. Okay.
Could you get us
Sure. Yeah, I will. Okay, remind me here in a second. Okay, determine the y-intercept, plug 0 in for x.
Is x
4 times 0 over 0 squared minus 4.
Ooh.
4 times 0 is 0. 0 squared minus 4 is negative 4. So,
No.
0. 0 divided by negative 4 is 0. Okay, so my x-intercept is 0. Right there. Oh, that was my y-intercept. My x-intercept, if I plug 0 in for y, 0 equals 4x over x squared minus 4. The first thing I do is multiply the ex squared minus 4 to the other side, which is going to make him go away. 0 equals 4x divided by 4, so x is 0. So my x-intercept is also 0. Because 0, 0 is an x-intercept and a y-intercept, so I have 1 point right there.
Origin. That's really sad.
The origin, I know. Like you did 2 things, but you only got 1.
Then
Point.
find the va.
Find the va. Va is denominator equal to 0.
Equals
We
x
can have more than one va.
What?
squared minus
We can have more than one
Oh,
va.
yeah, we can.
Okay, denominator equal to 0. So x squared minus 4 equals 0. This guy is a,
Minus 2.
yep, x plus 2x minus 2 is the difference of squares.
Oh.
So I have 2 vas. One of them is at
Plus
positive 2. One of them is at negative 2. Now, is one of those a whole instead?
Could. I gotta look again.
This
No.
guy
No.
is x plus 2x minus 2. Does he cancel?
No.
If he did, he would be a whole. But he's not. So we have 2 vas. Okay. One's at positive 2. One's at negative 2.
Wait.
Wait,
Go back up.
what? That's weird.
Okay.
Do we need to split it up?
What?
Or can we just
You could add the 4, take the square root. Yes. The only reason why I factor him is because sometimes when I take square roots, I forget the plus and minus. Versus if I make him a difference of squares, I won't forget it. What?
I'm confused what happened.
We'll see.
Why?
We'll see.
I just found
We'll see.
Yes.
We have 2 of them? Yeah. Sometimes that happens. Sometimes that happens. Okay, determine whether F has a horizontal or a slant.
He's 0.
N equals M equals.
Little baby. No.
Okay, what's N?
He's gonna be
0.
right in between.
Nope. 1. M is
2.
2. 1 and 2. He's bottom heavy, so
0.
he's going to sit his little fat butt at 0.
That's a hard va.
That's a ha.
Very good va.
Oh, he's crossing the ha. Do you see him?
No.
Look, we just drew a ha. And our dot that we already have on there is already crossing the ha.
I forgot how we find the hall.
We just found the ha.
I know, what did we do? Oh, we looked up the
then-
numerators in the.
Right, our dot is crossing the ha.
Bigger.
I know what he's going to look like already.
How is it crossing?
Because he's not supposed to go below it.
Because isn't this guy touching?
Add it. Okay.
Yeah, he's already touching. So yeah, there you go. All right, determine where F crosses its horizontal asymptote. The horizontal asymptote was a 0, and so we've already done this, right? We've already set it equal to 0, and we got x equals 0. That means he's gonna touch at 0, even though it's a ha, right?
So we have absolutely nothing.
We have absolutely nothing to go off of. Test for symmetry. I don't really want to do that. Determine the behavior of F on each interval. I don't really want to do that.
We're plugging in
Let's plug in some points. Let's plug in 1 and negative 1, just to see. I'm going to put my graph over here. 4x over x squared minus 4. I'm going to plug in positive 1.
Okay, so 4 over
1 and 1. So this would be 4 over
-3.
-3. So that is -1 and 1/3. That's when I plug in positive 1. So -1 and 1/3. He's going to do that.
Wait, hold on. For
Okay.
positive one,
For positive 1, he's going to be at 1 and 1/3.
It's just gonna be like a little
little tiny guy.
He's going to look like an x cubed in the middle. Kinda. That's just what he looks like. I don't know why. All right, if I plug in -1, 4 times -1 is -4.
It's gonna be positive.
-1 squared is 1, minus 4 is -3. So those negatives will cancel, so I'm at positive 4/3, which is 1 and 1/3. So he looks like that. This is what he's going to look like. Don't ask me why.
So wait, so the last one was -4.
Wait, you don't actually know why.
Well, not really. I mean, like, that's just how he looks. That's just what he looks
Why
like.
is he negative?
What you talking about?
He's negative. He's going down.
No, because I think his other little loop-de-doos will be positive over here. I think that's what he's going to look like on the other side, but we're going to find out.
Oh, what?
Why are we
Okay.
gonna find out?
Because we got to figure out what's going on over here in this quadrant, in this
We don't
quadrant.
care.
Yeah, we do.
No, we don't.
We don't even have the rest of it graphed. Okay, so I'm going to plug in 3 right here to see what he's doing.
Oh,
So
he is 12 over 5.
if you plug in 3,
'Cause
Are
it's
you
12
sure?
over 9 minus 4.
12 over 9 minus 4, which is 12 over 5, which is 2.4. Guess what? You can plug in some other stuff if you want to, but he's going to do one of these.
3 is what?
What was 3?
3 was at 2.4.
What was -1 at again?
4/3.
Positive.
1 was at negative 4/3. -1 was at positive 4/3.
Why is there so many?
Okay, if I plug in -3, he's going to be negative 12 over 5, which is
-2.4.
negative 2.4. Oh, so he's doing one of these. Oh, that's,
Uh-oh.
he's doing one of these.
Darn it.
The other side is just-
That's what he looks like. Huh, that's interesting.
What'd you think?
What?
What'd you think?
I thought maybe it was going to be like a volcano, but he wouldn't be a volcano because that would be, no, that's not
Why
right.
does he have that guy in the middle? Or like, why is there a bunch of things going
I
on?
don't know. That's just one of the things that happen. Sometimes what will happen is he will do, if he has 2 vase, sometimes he will do this and go like this. Or vice versa. Sometimes he'll be down here and he'll go like this. Or sometimes he'll do this. I don't know. It just depends. It just depends on what your values are. I'm sure there's a pattern. I just haven't studied rational functions enough to care or know. Okay, there you go. That's it.
Yeah, that's it.
Okay,
Some graphs.
yeah, that's it. I'll give you some graphs.